Hello, I am Dr. Douglas Giles. I am the Director of Education for the Society for UAP Studies, and we welcome you to the second of our UAP Studies Seminar Series. There will be an ongoing initiative by the Society of UAP Studies to bring to you, the general public, some of the research and thinking that is going on by experts in the field of UAP studies. Thank you for joining us. Just a brief word, the Society for UAP Studies strives to promote rigorous academic research on unidentified aerospace phenomena and anomalous phenomena through critical and open dialogue among various scholarly disciplines that contribute to a comprehensive understanding of this complex phenomenon. We're wishing to get past the stigma, the stereotypes, and the superstitions about UAPs and anomalous phenomena, and really have a true, rigorous academic and scientific inquiry into what is going on, because that's the interesting bit. If you would like to be a member of the Society for UAP Studies, please do go for societyforuapstudies.org. That's all one word, no hyphens, no underspaces. And please join us. It's $6 a month or $60 for a year. After April 1st, these seminar series lectures by distinguished experts will be behind our paywall, open to members only. The funding that we receive from your membership and your contributions goes directly to operations for the Society for UAP Studies and our ongoing research into the phenomena. Today, we are very, very happy and honored to welcome Mr. Rich Hoffman. Rich Hoffman recently retired following a 30-year career as an IT systems engineering analyst and contractor with the Army Materiel Command at Redstone Arsenal in Huntsville, Alabama. For over 6 decades, he has investigated and researched UFO or UAP phenomena, holding investigative and leadership positions with organizations including NICAP, Ground Saucer Watch, the Ohio UFO Investigators League, MUFON, SCU, SUAPS, or Society, us, and UAPX. He has appeared on numerous podcasts, television programs, and radio interviews, and has been featured in various books and articles. Additionally, he has delivered hundreds of lectures at universities and conferences and has co-authored several published journal articles. His title of his lecture today is Toward a Coordinated, Cooperative, Global Instrumented Study of UAP. I will read you his abstract, and then I will hand over to Rich, because I'm sure you don't want to hear any more from me. After decades of primarily anecdotal observations, recent technological advancements have made sophisticated detection and tracking platforms accessible to citizen scientists globally. While these platforms are currently at different stages of development and funding, it is critical for the global community to coordinate their deployment to ensure a maximum return on investment. Furthermore, there is a significant benefit to consolidating disparate databases into a common repository equipped with advanced analytical tools such as clustering, predictive analysis, and AI integration. This presentation serves as a foundational framework for establishing a coordinated global study of this phenomena. So, we welcome the Society of UAP Studies welcomes Mr. Rich Hoffman. Please, Rich, take it away.
Well, thank you very much. Thank you for having me, and thanks to SUAPS for also allowing me to come on board for this. It's a very timely kind of thing, because we're going through and we're doing a lot of discussions right now about technology. And as a scientist, or any scientist will tell you, we'd like to be able to have some very solid data with the subject. And I know that even back 6 decades ago, when I was going, I was living in Dayton, Ohio, and I got to meet, Hynek up at the Project Blue Book area, and even heard him present that, having data was very, very much the top of the need out there. I mean, good, solid data. And so there's been a lot of changes over my lifetime with the subject. The technology that I had back when I was investigating cases and stuff like that was very limited. It had an old Geiger counter, maybe you have binoculars. You'd have a compass with you or something of that nature. You really didn't have any internet. You didn't have anything like a cell phone or any of that nature. And so over my lifetime with this subject, I have seen a lot of advancements. The technology has advanced incredibly exponentially, and the costs have even come down to the point where you have a lot of developers out across the country and across the world who have actively been engaging in developing technologies to be able to help get that. My goal and my push on this subject has always been, we need to get that data shared that you're collecting on all those like UAP, and allowing for scientists to be able to now work and deal with that and add it to getting more than just again the anecdotal data that we get, and so much of Project Blue Book and everything else, and a lot of even the MUFON cases are anecdotal testimonies. I saw a UFO last night. It did this. It did that. Well, I happen to get a blurry picture that I can give you, and you can take a look at it, and that proves that I'm not a nutcase, because there's a white little dot in this. So ultimately, we need to get beyond that, and that's my goal here, is to tell you more and more about that. Let me get into my actual presentation, and I'll hang on one second while I actually bring it up. Okay. Hopefully all of you are seeing this, and if you would tell me otherwise if you don't see the full screen of this presentation. I'd hate to go through the whole thing and you not being able to see what I've got here. All right, as mentioned, the title is Towards a Coordinated Cooperative Global Instrumented Study of UAP. That's a change in my lifetime. It used to be called UFOs. Now it's UAP, right? I'm an executive board member of SCU. I'm an advisory board member of SUAPS. I'm also a lifetime member and benefactor to MUFON. I've been at this for quite some time. You kind of like talked about it. I grew up in Dayton, Ohio, where Project Blue Book was. My 8th grade science class had a topic that you had to put your name next to and speak for 10 minutes. I was late to class, signed up for and the only thing that was left that nobody put their name next to was UFOs, and I'm the stuckey for it. So bottom line is, I bombed the assignment. I really wasn't interested in the subject, and to show you, I think I looked up 2 books, My Trip to Venus or My Saturnian Lover or something like that, and then little did I know that my science teacher was going to hit me with questions like, well, what about jet pursuits? What about this? What about that? I'm going like, what did you read? Anyway, a couple days later, I actually got the first book on it, which is a report on unidentified flying objects by the former head of Project Blue Book, Captain Edward Ruppelt. And I began getting now very, very interested. When I went home that evening, they were talking about the Socorro, New Mexico case in 1964. That was April 24th, 1964. And that's probably well before many of you were even born. So I've been at this a long time. And at the age of 15, suddenly I ended up on a show called the Phil Donahue Show, which was a kind of like a national TV, or he went to becoming national. And that kind of made me here's this UFO guy in Dayton, Ohio, where a project is. And suddenly I was on radio, TV constantly. People were asking me to lecture. I was going around doing lectures on the topic. I had done a lot of homework. I had collected every newspaper article, everything I could get on the subject, and away I went. And so suddenly I was called by the station to go in and be on that show at age 15. I joined the Midwest UFO network, which became the Mutual UFO Network later on. And in 78, I had a symposium in Dayton, Ohio. I got my degree from Wright State University. I started then working with the Army Material Command. I've been with them for 30 years. And as was said, I retired from that, doing IT work with them. We moved to Huntsville. I live in Huntsville, Alabama. I was with Alabama MUFON. I was a state director for Mississippi. I was also for Alabama. And then I also went on to become the Deputy Director of Investigations for MUFON headquarters, and then became the Director of Strategic Projects, which was basically to put technology into the equation. And then later in 2017, I moved from MUFON over to Society, SCU, Scientific Coalition for UAP Studies, and helped form that organization. And going on, and of course, working with SUAPS. In 2022, I had the pleasure of being with Ryan Graves, and the two of us went over to a NATO meeting in Bologna, and introduced them to the subject as well. So I just want to give you the fact that I've even played at the global level before. And anyway, over on the right, you can see a picture of me. That was done by somebody at the Army Material Command, and you can see all the UFO stuff around my desk. I didn't hide the fact that I was into UFOs at all, or UAP, and they knew it. So anyway, instrumented studies.
Hey, Rich, I'm very sorry to interrupt. I think you have the wrong tab on your presentation up, because we're seeing a blank screen.
That's what I was hoping you'd clarify to me.
Yeah.
Okay, hang on 1 second. Let me get in there, because I want you to be able to see this presentation.
Yes, we definitely want to see this.
Yeah, I know. So I'm going to see if I can get in. Hang on. I don't know why this thing is not being cooperative, but let me get into it again. And StreamYard is just really strange. It's like so easy to do in other packages, but for some reason it's not here. Can you see this?
Yes.
I'm gonna make it full
screen, but yeah,
it's now full screen, right?
No, we're back to me and you, unfortunately.
Well, why is that? I've got full screen, and I said share full screen.
Sorry, folks.
Okay, hang on a second. Let me.
You had it there for a couple seconds.
Share screen. Window.
And then you probably need to hit present again.
Can you
something's coming up? Yes, perfect. Thank you very much.
Now, you're not seeing it full screen, right?
Yeah.
Hang on. Is this full screen? Can you see it?
I can see your window, and I see UAP detections. Right. I can see the browser status bar up on top, but this is fine. This is fine.
So you can see the screen.
Yes, I can. Yes.
All right.
And
all right. Well, I'm going to go with it then. It's not in full screen on my computer, but I'm just going to go with it this way. Okay.
Okay.
Can you see the change that I just did?
No, sorry.
So you're not seeing my background right now.
What I'm seeing is the UAP Detection Summit 2026.
Okay, that's not what I want you to see. All right. Okay. So I'm going to close that down.
You probably have multiple monitors, yes?
I do.
Okay.
But I've got it. I have it on both of the screens.
Okay. Well.
Okay. I apologize. I don't know. But this is why I wanted to come on early and to go through this with you, because it's ultimately.
Yeah.
But I only have this problem with StreamYard, and so it's an issue. I don't have this with Zoom or any other package. Let me see. Mm-hmm.
Hi, Rich. I'm going to come in and if you send me the slides, I can present them for you.
All right, I'll send them to you because this is ridiculous.
Yeah. And then and then you can just sort of tell me to advance, and I'll be there for you.
Okay, thank you.
You're welcome.
And we apologize for the technical difficulties. Technology advances and technology sets us back sometimes.
Mike, I'm sending them to you in a PDF format. We'll show them from there, okay? Because this is rather large. Okay, I've just sent them to you.
So again, I apologize to everyone. Please be patient. We'll get this technical problem sorted out.
Do you see my presentation now?
Study of UAP. This is perfect.
You see that?
Yes.
Okay. I think I played around with this enough. I think I found out how I can do it. So can you, we can go ahead, right?
Yes, please.
And I'm going to see if I can now move the screen here so we can see the next slide. And I'm trying, why doesn't it advance now? Let's see.
Hey, Rich, I think I'm the controller here of your slides. They're visible perfectly. So
Okay.
if you just, I'll
Can
just,
you do?
you tell me advance and we're
All right.
good.
Can you go to the next one? Advance. Can you do it?
Yep.
All right.
I got
So, all right. Well, anyway, that was my background. That's the photo of me in the UFO. I'm actually an alien. That's if you look at my face, it's like behind it's an alien head. All right. So anyway, let's move on to the next slide and let's get on with the presentation. History of instrumented studies. I mean, if you take a look back throughout history, you can find out that, all the different projects had a little bit of instrumentation to it. Project Sign had military radar. You had pilot instruments, gun camera film that was taken from 47 to 49. From 49, Project Grudge came in. There was a little bit no change, pretty much. It was just, down at that level. And for the government, there wasn't really too much in the way of like citizen stuff going on. But Project Blue Book, you also had, from 52 to 69, they ground airborne radar, optical photography and film, aircraft telemetry. There was a little bit of that. You had also radar again that was being used, and there were a lot of other types of experience. So the significance here is large pre-digital instrumented archive would exist, and then limits, of course, not persistent, purpose-built sensor networks. And then in 66 to 68, of course, you had the Condon Committee, and you had a little bit of instrumentation there. You had radar data, you had photographic studies, but the outcome was basically public dismissal of it. You had internet dissent, had acknowledged, and nobody really appreciated that study, including Jacques Vallée and Hynek and a whole bunch of others that dealt with it, and certainly, James McDonald. There wasn't too much in the way of any kind of like legitimate good study with that. Next slide. 64 to 1990s, you started to get into a little bit of that, a little bit better equipment and stuff like that. So there were efforts by some citizens, 64 to 79, there was a Project Starlight International, which was, I think, Ray Stanford that was doing something like that. He tried to have a mobile vehicle that was doing things like, it had magnetometers, spectrometers, laser telescope kind of systems in place, and all that with the idea that you could take the mobile platform and go where you needed to, and then and being able to do something with it and collect data. And then from 77 to 2004, Japan, which then became SEPRA there for a while, was getting into radar photogrammetry, atmospheric sensors. They had the first state-sponsored science-based, science-forward UAP program. And then, of course, the host agency was CNES, which is the French space, like we have NASA. In the 80s, you had also Hesselen Valley that was going on. And I know that even Hynek visited the Hesselen Valley when Erling Strand was doing that. And bottom line is they had a very much a site or specific building, they called it the Blue Box, if you would, that was fully equipped with all kinds of things, and eventually that progressed, and it's still going on, by the way. It's amazing. It is the longest running continuously instrumented site. And then the other thing that's nice about it is that they have their data is publicly available so that you can continue to do studies and stuff. Next slide. So in 1990s to 2000s, you had some independent scientific initiatives that were going on. First off, you had NORCAP, which was Ted Rowe and Dick. I can't remember Dick's last name. I'm sorry, but anyway, they were basically out doing aviation radar and looking at flight data recorders, cockpit instrumentation, and the focus was aviation safety. And so there were a lot of efforts to look into the phenomena and look at the data from commercial aircraft as well as regular private pilots and stuff like that who were actually collecting information. And it's still ongoing. 2007 to 2012, you had classified hybrid programs. For example, you had OSAP, which the NATIP. Those two were both, using everything from military radar, targeting pods, FLIR kinds of stuff, satellite data, if they could get it classified, focus on, the aerospace threats and anomalies. Again, this was actually, a contract that was put in place, I think through DIA. But anyway, you had, and then it moved into this ATIP phase, if you would, still part of the same program, where it's ultimately now looking at just strictly the UAP phenomena. And there it was using, like, in the naval radar, you had like the Nimitz case, and you had the FLIR systems, electronic warfare sensors, had, of course, during that time, you had the Roosevelt sightings and stuff like that Ryan Graves mentioned that they were seeing for like every day for 2 years. And again, this was now starting to get into a multi-sensor confirmation of the anomalous performance data. So it's not just one sensor or one thing. It's not just whatever. It's multiple sensors. And of course, that's what we're looking to move into. Next slide. In 2000s to present, you have a lot of different things that are still going on. You had also 2000 to 2021. Of course, it shifted over from ATIP to the UAP task force. And again, they were using military multi-sensor fusion kind of data. They were looking at unknown objects, acknowledged the limits. There was no civilian transparency, and that's pretty much where a lot of it still kind of is, in the sense that you really can't get deep down data from even Aero, which I'm mentioning here in 2022. Aero is, of course, looking at radar, space sensors, and trying to use multiple platforms to be able to deal with that. They were reaching out with, of course, with NASA to be able to have them on board and look at curated data and what can we get from any kind of satellite data, and so on and so forth. So it's about trying to be able to now actively go against a lot of different things. Can you use NOAA weather, NOAA radar, for example? Are there other kind of platforms that the whole government has that they can use? And so it's trying to look into that as well. And then then you have also the AVI, LOBE, and the Galileo project coming in, where they're trying to put out platforms. I think that they've got 3 locations down where they've got all kinds of technology that they've been able to come up with. Again, multi-sensor, to be able to go and look at UAP and to be able to see what that they can find out from that. So it's very, very much a scientific kind of endeavor on the part of the public. Next, please. So we're now going to focus on this citizen efforts and see what we can come up with. Let's go to the next slide. And here what we have is, if you take a look at it, probably pretty much everybody knows that there's the Skinwalker Ranch ongoing investigation using like technology tools, and you see them out using everything from drones to a whole host of things. They got spectrometers, they got spectrum analyzers, they've got a lot of different things going on, and it's about using technology to be able to look at the stuff. And of course, that they do see from time to time UAP in that area of the ranch and stuff like that. So the problem that a lot of us have with it is that it, of course, it's on TV and everybody turns it into entertainment, and it's got the entertainment. It's also, when you talk like with Travis Taylor and you talk with Eric Bard and them, 1/10 of what they actually do gets on TV, and so the 9/10 of what they're doing is actually a little bit more scientific, and that doesn't get on the TV. So anyway, my hope is, in talking with them, that they'll publish something and we'll be able to get some documentation and data, and they can even let us analyze some of those videos that they get of these strange objects. Next slide. UAPX had a show that was on a tear in the sky. And that was put on a number of years ago when they did a 5-day instrumented study near Catalina Island. And they took out all kinds of equipment, FLIR kind of equipment. It had multiple sensors to be able to do it. And over the course of the 5 days, they had certainly collected tons of data. And it was a matter then to be able to, how can we get, some sort of team together to be able to do the analysis of all that 5-day collection of data. Well, that's a very significant concern, in the sense that, if you're going to go through that, and, Dr. Matthew Shadegas also went and put machine learning in place to be able to help out in terms of culling out some of the known stuff to get to the more specifically interested unknown stuff that we wanted to take a look at. And it was a primary example of what instrumented studies could deliver. And it was just volumes and volumes of data. Again, you have to have that neck down to be able to get into something that you can actually deal with. And then you have to have people that were available to be able to look at all that wonderful data, go through it, try to interpret it. And it's a big challenge. Next slide. I mentioned Hestel in Norway, and of course you see that there's a box, a blue box up at the top of the hill. They've had other platforms that they've gone out with, and they've been able to go out and collect a lot of data, and they make that data available. They're also advancing their technologies that they've got up on that in that area. Hestel also was they call them the Hestel lights, but they see more than just the light kind of phenomena. They also see solid objects or disc-shaped objects or various other kinds of things out in that valley. And there are other kind of places like Hestelin. I will point out to you that like an hour away from me in Cloverdale, Alabama, you also have a situation where for like the 70s on, you had Earth light phenomena, which are kind of odd, and people call them spook lights. In the 73 roughly time period, you had the Piedmont, Missouri kind of like lights that were going on that were an unusual kind of atmospheric phenomena that where if we actually get to understand those things, we might be able to eliminate them as UFOs, and that would help drive our population of unknowns down. But and a lot of people misidentify Earth light phenomena, whatever they are. But we're getting closer because we're actually taking spectrum readings on some of the lights we see, and we find out the nature of the gases are everything from nitrogen, oxygen. It's got sulfur, it's got an iron content to it. In addition to that, it has these rare earth elements that are called yttrium or scandium, which are also part of it. Interestingly enough, scandium is used in Hollywood to be able to take nighttime sets and make them look like daylight. So it has an illumination aspect to it. But these are natural phenomena, again, that we just need to understand. And the Min lights in Australia could also be that. And again, it's just a matter of us finding out. But I want to point out there's also solid objects that are being detected. And also their sensors are picking up, for example, motions when they can't actually see objects. So one of the problems we have is if you can't see it, obviously you're not going to be able to report it, but yet there's objects that are showing up. In addition to that, you also got the problem with trying to understand where the hot spots are. Well, not everybody reports their sightings. In fact, the vast majority of people don't report. And so we really don't truly know where all the hot spots are. We believe that we might. But that's what we would like to be able to do, is to go to these areas where there's repeatable phenomena and set up equipment. Next slide, please. There's also an effort going on by the Tedesco brothers. They're basically equipping a mobile van with, it's probably, the most costly mobile van that I think I've ever seen in my life. And John and Jerry, I tell them all the time, I said, I'd like to have 200 of those things across the United States. That would be great. They're currently located up in the Northeast and stuff like that. But they do get that van out and go to different places. They were down in Jersey when the drone things were going on, and they try to cover a good area. And man, are they equipped? They are equipped to the gill. And they've integrated their sensors, and they've got a lot of control to them, which is what we want as well. So bless them for doing what they're doing. And again, I'm glad to have them on board with helping us to figure out what's sensible and non-sensible at this. They have also moved to the fact that they've actually got a boat. I said, well, great. I mean, if you think about UFOs, we've got maybe pretty much the air covered, but we don't have space and we don't have water covered very well. There's not a lot of technologies in either of those domains, and yet we know that there's a lot of reports around water, above water. If you take a look at even those exercises on the east and west coasts, you'll see that water's engaged. And anyway, I just wanted to point out that those are the other domains we have to work on. Next slide. So just recently, we had a summit that was held by the Human Institute. It was on the beginning of February, on the 7th and 8th, and some of you may have gone to it. Hopefully you did. It was an excellent thing. We had over 500 people that signed up for it, and we had over 31, I know over 31 different players that were actually presenting. And you can see on the left there were a good number of these people, everything from Ron Ulch with UFODAP, Richard Hopf out of Austria with Sky 360. We had people from Germany as well that were engaged in that. The Skywatcher effort with James Fowler. We have Alderon, which is basically David Hooper, who has got a very elaborate kind of like setup there that he's put together. We had Madar, which Madar was something that was early on by Francis Ridge. And sadly, we just lost him. He passed. He was out of Kokomo, Indiana, and had been at this for a very long time and put this tool out, which was magnetic kind of detection systems. And he had it centralized. And so it was a great effort for that. Picked up a lot of different unknowns. Again, I mentioned the Nightcrawler just now with Jerry and John Tedesco. We had MUFON was on talking about the fact that they're also getting in and helping to develop an app to be able to help out, which is an excellent effort. Robert Spearing touched on that. We had the Vasco project. Beatrice Villarreal was also talking about that. And I'm glad to have her on board. Hawkeye 360, which was Robert McGuire and Gene Greeniker, are taking an effort and building a new platform as well. It's a lot more elaborate than Madar, but I mean, it's got all different kinds of things that he's building on that, and we're encouraging them on. The AIAA, which, by the way, Michael Lembeck also showed that there's at least I can't think of the number, but it's like close to 10 different platforms that they've got that they're helping to get out there as well to be able to do UAP studies. And we want to thank them for that, and that's great. We had Eamon Onsbro from actually Ireland. SETI Kingsland is what they call it. They've got a whole bunch of gear that they're putting out and trying to work with. Fred Paulson and a number of other players from the Heslin area were on board. Mitch Randall is looking at passive radar, and he's got Ascendant AI, and he's trying to be able to get that out there. And then you have an independent study that was by Roni Bernet that was also talked about. Key points, the majority of these are willing to share their data. That was a very good outcome from that. So again, they're willing to work with science. Many of these already include machine learning and AI capabilities to assist in their analysis, and also can filter out and eliminate the knowns basically from their platforms. And so that's also a good thing on the part of these instruments, being able to actually see that. Then we had a presentation by Massimo Teodani from Italy that also stressed the need to be able to distinguish between, again, solid objects and those that are similar to like plasma-like objects or Earth-like phenomena. And he briefed us on a lot of different ways of doing that. Excellent, it was really, really good. Next slide. Wonderful. We had other people that were Gary Nolan was on board. We had, of course, Richard Dolan, who was helping to talk about USOs and stuff like that. We also had Eric Burleson, and we had also Michael Gold from the NASA efforts, and a whole host of others. And it was just an impressive conference that actually that really was just now helping us to get on board with making progress and coming up with some sort of collaborative way to make instrumented studies happen globally. So next slide. Hello, next slide. Is it not moving? Well, I don't see my next slide, so I don't know what's going on. All right, so best equipment for citizen science. Let's move into that type of thing when we talked about what equipment can we get recommended, what types of things. Well, a lot of it, tends to fall into the optical and imaging systems, the primary evidence layer. It's like, do you see something? Everybody wants to see something, and so our eyes are, the very prime focus. And of course, that's what, you have a lot of witnesses all doing the same thing. They tend to focus on that. So we want to see the shape, the motion, the acceleration, the luminosity, and very other kind of characteristics with our optical systems. We just recently have only started to be able to see, for example, the videos like, even in the Aguadilla case or the Nimitz case, where you're starting to see, military grade equipment that's able to now look into the midwave IR range. And so we want to learn more by seeing across the electromagnetic spectrum and other kinds of ranges, UVC and other kinds of things. And so it's very critical that we are able to do that. There are high-speed cameras now that can go from, get up to above 1,000 frames per second. And, you want to get into that. You got low light kinds of things. Cameras are improving on their ISOs. They're up in the millions. You can actually take a nighttime shot. You can completely see, it looks like daylight and all the colors associated with that and all the background. And so we want to be able to get the best cameras. We want to get all sky cameras to help us to be able to detect and look at 24/7 sky coverage. Motorized tracking telescopes that can track something. Again, it's about detection and tracking of the objects. We want to be able to get spectrographs. We want to be able to get their emission and its absorption analysis. We want to do that. So it's all those things you find out, like in astronomy and stuff like that, that you want to be able to now apply. And why it matters, it enables our kinematic analysis, our, about, instantaneous acceleration. Is that really a factor? Is that the thing that's going to help convince you that it's definitely an unknown? That the fact that it went from a hovering position to shooting off at Mach 50 instantaneously. Do we have things to be able to track that kind of thing? And spectral lines can also indicate plasma, propulsion, and ionization effects. So the fact that we have the spectral can help us to do that. All sky systems also prevent cherry picking of events. Next, please. We have, as I mentioned, the infrared, the thermal, and the non-thermal ranges. You find out, how can you have an object that's not heating up in the atmosphere and appears to be like colder than the background and stuff like that? And can we detect heat or the absence of heat? And again, if you start to get into midwave IR or long wave IR, then you get into these thermal ranges. You can have near IR, but it's not as effective as getting into the midwave IR, and especially that's very, very good for you. And there's equipment out there you can get for that. You also have the tracking gimbals on these things, and that can be an IR where it can actually track objects and move along with them. Again, why does it matter? It identifies propulsion inconsistencies, or the fact that you can separate out an aircraft from a non-aircraft. As you can see in the image on the right there of the aircraft, you can pretty much make out the thermal signature on that plane, and you can see where the dark spot of the engines are, and it can help you to do that. Well, we see objects that are just one solid color, and that clearly indicates that there's no kind of heat. And then many times we may have it set for black is hot, and yet the thing is white. And so what is that about? It helps us to be able to look at that. Again, is what I was trying to say, that we don't have any cooling or heating in the atmosphere. Next, please. They also have radar and RF detection, object reality checks. As I mentioned before, in the case of Hesselen, they talked about the fact that they were picking up on their radar something that was moving that was not visible. And I remember talking with Erling Strand about that kind of phenomena, and I'm sure that that's happened in other locations. So again, we want to determine the physical presence. We want to be able to see if we can, to track those objects using that kind of thing. Passive radar is one of those things where it seems like we're trying to be able to get into, because it's relatively cost effective for us to be able to do that. And you can use various FM antennas and a whole various other kinds of things to be able to make that happen very inexpensively. And it also lets you see the object and its speed, and that's what we want as well. Active radar we'd like to have, X-band and S-band were permitted. I know that the Tedesco brothers have the X-band for sure. They probably even have the S-band. I don't know. But I mean, bottom line is they're getting into active radar and using it for their observations as well. Software-defined radios, SDR, broadband, RF capture, those are key instruments there that would help us out. Why does it matter? Passive radar avoids emissions and interference issues. It confirms speed, altitude, cross-sectional kind of like pictures. And you start to get in radio frequency anomalies may correlate with UAP events. I worked on a project out at the base where we were building and putting out in DoD sensitive areas. These are our critical areas. We were concerned, and we still are concerned, about drones. And so we built drone detection platforms for our military bases. And one of the systems we were putting out there was called the Corian system. The Corian system had with it everything from listening for the drone around the perimeter of the base. Acoustically, it was also looking at spectrally. It's also looking at, like a sonar, or not sonar, but a radar type of thing as well. And it used all these different sensors to be able to help you to detect the drone. And then in addition to that, they had other things where it would help them to be able to locate where, if anything, the remote operator was located. It could do that. And additionally, it had the means to knock out the drone that's coming around maybe the perimeter. And so we've got drone busters that we were adding to the DoD inventory, and now being able to go after those types of things. Well, obviously, if you have a UAP that's coming in next to your base, your drone detector is not going to knock it down too easily. So it might help you to do something like to distinguish between what's a UAP versus a drone. But anyway, the drone problem continues to be a big problem that we're going to face from a defense posture. And again, it's going to be one of those things where you could take a look at even ships like that doing exercises, like the Omaha and various ones off of the West Coast, where you'll hopefully be able to have these drone busters to just bring down the drone, if you would. But drones are advancing in their technology exponentially, and they're often confused by the public with being UFOs. So it helps us as UAP in our research to be able to eliminate that aspect, along with those things I mentioned before, like Earth lights and so on and so forth. Okay, next, please. It's also, getting into things like, geophysical sensors and environmental sensors. By the way, I want to bring up the point that you also need to be able to check your background, environment wherever you're at, because there are things that could be coming into play that could be causing all kinds of your sensor readings that might go off. And so, you have to balance out what's environmental background noise, and whether it's using electromagnetic sensors to be able to look around at different parts of the spectrum and seeing what you can come up with. But anyway, key instruments are things like magnetometers, can look for magnetic disturbances, electric field meters. You might have radiation detectors, looking at gamma and neutron or beta. Atmospheric sensors, looking at everything from humidity, ionization, and pressure, to acoustic arrays and infrasound. I bring this up all the time because, it's like a lot of times UAP witnesses will describe the fact that they're completely silent, even when they're close up to them. And they take off at incredible speeds, but they don't hear any noise. Well, is it because that it's above or below human hearing ranges? And so if we had, the ability to go look at infrasound or ultrasound, we would be able to find out whether they are making indeed noises, and we can try to capture that to help us to understand that as well. And of course, I want to bring up spectrum analyzers, looking across that spectrum. Why does it matter? It helps identify electromagnetic or gravitational-like interactions that are going on. You're looking at, you can help you to separate that plasma from weather effects, and it supports the physical interaction hypothesis. So again, these are very, very important to have. and they're very inexpensive, by the way. Next. So, there's also, when you have all these like multiple sensors, you got to have like precision timing and location synchronization that's going to have to take place. So you have all these key instruments with, different time clocks and everything else. And so you need to be able to bring it together so that you now can take a look at that there's been an event that's happened and all the sensors are now like focused on that to be able to now get that precise timing and location and kind of thing going on. So everything from your, whether you have GPS discipline clocks with nanosecond accuracy or atomic clocks or what other kind of clock units you're using, you want to be able to do that and use that whenever you're doing it. Why does it matter? It enables triangulation across sites. It allows the reconstruction of true trajectories, and it makes data sets significantly defensible. So the fact is that you have to have the timing for the multiple sensors on that. Next, please. And then, data architecture and autonomy, again, long-term, you have to have an architecture or construct here and an autonomy. Long-term, unattended, scalable operation, if you have to be there. For example, when I was going out and doing what I was doing out in Cloverdale, I'd be carrying all this equipment with me, going to another location and stuff like that. If I can have something where it's positioned at that, in that location all the time, then I would be able to always be collecting that data and stuff like that. And then again, allowing me to be able to get that information. So if you can have these things positioned and then have it being able to be, it doesn't have to be attended, but I can be sitting off the location and now be looking at the data. I can analyze that. And of course, that's like Hesselin has got that as well. And a number of other sites as well that can do that. But again, you have local redundant storage. You can look at using the cloud more. And some of this information, like, I was talking with the Sky 360 people, they're collecting so much from their platforms that they've got like petabytes of data. And that's a huge amount of data. So you can imagine if you've got a global amount of data being collected and it's raw data, well, then we're going to be in a problem. But we need to be able to get to that point where it's called down. AI or MLs help us eliminate some of this stuff. And then we can truly look at just a small amount of data. And for the event, then we can do something more easily with it. You also need to be able to have these platforms out and be tamper resistant, if you would, because you can have a platform out there where it's out in the field and it's in a spot, and the next thing you know, it's walking on you, and you find out, well, wait a minute, somebody's picked it up. They found it and it's gone. So you have to have the means to be able to monitor it, make sure that it is where it's at, and that you can protect it. Next, please. We have to look at the deployment strategy. Where's the best places to do this, and what's our best practices for doing that? And we're talking about that now. Is that these mobile platforms, how are we going to do it? Do you go to coastal, offshore, air traffic sparse zones? Do you go to hotspots? Nuclear is a hotspot. Well, okay, great. Do we go to a nuclear base, a nuclear facility? We hang out there, or what? Do we go to the try to go to these locations offshore where they have these missions that the Air Force or the Army's having, or the Navy's having, or whatever like that? Where do you go to put your platforms? And again, who's going to do that? How's it going to be handled? Is all very, very critical. But you want to be able to gather data, and you want to be able to get this. And nobody knows when the UFO is going to appear at any given location on this planet enough to be able to predict that. We've talked about having honeypots. Well, let's go put something that looks like it's nuclear out in a field, having, whatever, and then setting around the entire perimeter, all the cameras and everything else we would like to be able to get. And that would be wonderful. And then, of course, you have the people at Skywatcher saying, well, they got the dog whistle. Well, they got some sort of thing that attracts these objects. Well, okay. It's probably some sort of like a signal that they send out, maybe at the microwave range or something like that, to be able to trigger an interest, if you would. We need to figure that out, and then we need to be able to set it up and then make sure that we've got, those standardized sensor packages to be able to help us to identify it, and then looking at independent scientific oversight of that. And that's a global need because this is a global phenomenon. We want to avoid single sensor setups as much as possible, human triggered recording only, proprietary black box systems, and anecdotal or post-process only data. That right now we're dealing with the fact that most of our studies have to do with old data out of Project Blue Book, old data out of maybe some other locations and stuff like that. And it's all anecdotal data, and so there's not a lot with it. So how far do you think that we're going to progress in our studies if we continue to do using old data and old kind of like databases and various other things? And we're not going to go very far. So we've got to get our act together globally, and that's what I'm pressing for. Next, please. So bottom line, UAP understanding will only advance through synchronized multi-domain persistent instrumentation, not eyewitnesses or single sensors. And I want to emphasize that. We're not going to get very far unless if we continue to do what we've been doing for the last 70 plus years with this thing. It's got to change. And it's about the fact that we all need to come together and work on that. A properly designed remote system can rule out in conventional explanations early, identify genuine anonymous events objectively, and produce data suitable for peer-reviewed science. Next, please. Our most daunting challenge, of course, is that most of these things I'm talking about, like that night crawler and a whole bunch of other things that are out there, UFO DAP and all the Sky 360, is that it comes out of local people's pockets. They've been out there developing that because there's no centralized funding to help that. And as you very well, I've just elaborated, if you're really going to go after this phenomena, it's going to cost you. And even just getting a proper database to be able to do it, making sure you got security and being able to access that, to all of as much as we'd like to, has a cost. And then the addition of that, you've also got the staffing data resource funding challenges. Most all of these people are working, hand to mouth. Of course, they're out of their own hide, and there's like one-offs. They've got, it's just one person or two people or whatever, and so we need to be able to get some sort of way to get this funding going on, and it's going to require that every organization out there that wants to have access to scientific data is going to help to be able to fund it and to put that in place, and then they get access and work cooperatively together with their studies. There's got to be a cooperation to share again. And I mentioned a lot of these partners and players who have been developers are willing to share. They all admit that they were willing to share their data. It's the data integrity, the validity that we need to be able to have. We have to have security, data security, and data volume that we'll have to address. And these are again, funding challenges. Next, please. So the strategic decisions. What can we do to maximize detection in a cost-affordable way? Can we use a layered approach on hotspots once we identify, meaning that we have some sort of detection tool that's a low-cost thing that identifies those key areas. Then we send in multiple layers to that area when we see that there's some strong activity going on in that area. Can smartphone apps? I've been pressing for smartphone apps for a long, long time. We're all walking around with these devices, which have everything from accelerometers and various other things on them already. And then there are tools like, you can get better apps that are out there that help you to do things like, trigonometry and everything. There's one called, I can't remember it off the top of my head, but there's also Phenom that's put by Len Logan, I guess, or that's out there that's available. I know that also MUFON is going to be offering one as well to be able to collect that. And then also Elderon is also looking to, or has an app that's going to help us out. So again, if we can start to leverage some of those things, at least be able to now do a lot more. How can we coordinate the deployment, training, security of systems deployed again? And do we focus on one domain? Should we just focus on the air and forget water and space? It seems like that's prominently where we're going right now. But wouldn't it be nice if we have tools to be able to at least put on ships, or how about on private aircraft? Pilots, and stuff like that can have something, the tool. You can also talk to other parties and see if they are give them something to be able to work with, and that would help us out. So next, please. So what are the steps to be able to doing this, implementing a global instrumented study? Let's go into that next, please. So I try to lay out some steps to be able to help us to think through this whole thing about how do we do it. We need a neutral scientific coordinating body. There's got to be some organization or something put in place, whether it's a non-governmental, by the way, is encouraged, create a non-governmental multinational consortium or something like that. Somebody that's a trusted and legitimate and something that's going to lead that effort, if you would. And then it's working, if governance is included, you should include things like atmospheric scientists, sensor and data engineers, astronomers, and defense adjacent observers can be a part of it as well. But don't have them in the key roles. But having, again, a non-governmental effort going on, because we aren't getting too much from governments. The governments are keeping things either in a classified way or keeping it protected, and we citizens just don't get anything from it. And this is a global phenomenon that needs to be presented globally to humanity, by the way. Charter explicitly excludes conclusions a priori. The key principle is coordinating without central control, and this avoids national security paralysis. We don't want to get into that. Okay, so next, please. The next step would be to maybe define a shared operational definition of UAP. One of the things I talked about is a taxonomy. We need a taxonomy that makes sense. Is what's an orb versus a spherical object, or what is even our notions of triangle-shaped objects. And if we can come up with some sort of taxonomy that allows us a clear definition of these different distinguished things, would be very, very helpful. Orbs are everything from Chinese lanterns to Earth lights to plasma type of balls of light and everybody uses that term orb, and it's even in the ghost phenomena and stuff like that where they talk about orbs and stuff like that. So we need to come up with a better way of dealing with that and have an overall semantic kind of taxonomy. We need to standardize what qualifies as a UAP event versus other things. Classification tiers like unexplained, partially explained, unresolved. How we classify that is going to be very, very important. And this is where we need to get all these things standardized, if you would, that would help us out. And separate phenomenology from interpretation. What was observed does not equal what it might be. And we need to publish, again, a UAP taxonomy. Next, please. 3, standardized instrumentation and sensor metadata. So again, we want to be able to standardize as much as we can. We need to work with the data at a high level. Minimize your sensor standards. Go with optical, visible, and IR, radar, RF spectrum, environmental sensors where you can, and require all of the metadata associated with that, the time synchronization, the location, the geography, the GPS information, the sensor calibration information, and all that metadata that's behind the scenes needs to come with it, because you need to be able to look at that. Uncalibrated data might be archived, but not used for conclusions. There's no reason you can't use some of the uncalibrated stuff, but at the same time, try to go with calibration as much as you can, curated data as to the best of your ability. Next, please. Number 4 is create a federated global data architecture. Again, let's look at, how we deal with data, because data is what we're trying to go after. And using a federated model, not a standardized data, a centralized database, you can go with that. You can go with data that stays with originating nation and institution that maybe gets over some hurdles. You can use queries, and analytics are shared, so you can query and analyze the data. And again, allows those individual partners and players to be able to now work with their data in their local areas at the same time. Just give us the stuff that's the unknown that we want to look at. Common data schemes and APIs, those are your interfaces you need to look at. Tiered access, you can give it to the public. You can look at, some access to the public. You can give some more to the scientific collaborators, and then you can have a restricted area as well. This is how astronomy and climate science already work. So let's take a model that works with and move along. Next, please. The next step is implement a multi-sensor correlation protocol, which is basically to reduce the false positives and misidentifications. So you're looking at everything from optical plus radar, cross-validation. You're looking at multi-geographically separated sensors. You're looking at automated correlation pipelines that flag known aircraft, satellites, and atmospheric phenomena. So, again, you can use ADS-B if you can, or any kind of things that help you to now eliminate those false positives, if you would, that are out there. And then, you become, a residual category as opposed to not a catch-all. Next, please. Number 6 is transparent reporting and peer review. Well, obviously, you want to be able to have transparency in terms of reporting. You also want to do the peer review, and we want to be able to get the data that we've got out to other scientists, let them look at it, be able to help come up with, are we right? Are we wrong? Where do we go wrong? And of course, if all these parties and players I mentioned before are doing these like platforms out there and stuff like that, they are doing that to collect data, but are they going to the process of peer review and looking at the data and actually having people analyze it and come up with papers that are publishable? And what we want to do is to be able to learn from this thing. And so it's ultimately about how can we have information put together in such a way, or data, and to create information which then helps us to create knowledge. And so it's a very important thing that we need to be able to do with that. And transparency also, by the way, helps us to build trust. That's one of the things you don't have with the aero and the government kind of things, is the lack of trust that we have is because you don't share data and information. All right, so we want to get away from that. So number 7 is incentivize participation. You can incentivize it as much as you can. You can get into allowing for contributors to be able to help that. We certainly need donors and everything else to be able to help us to get going on this, and we need to have that plan worked out. But it's going, you can build the case for it. It's going to help us to improve airspace safety. That's a concern that's out there. Airspace safety. We're getting our understanding of atmospheric and other kinds of things going on. I mean, science has not done a very good job of looking at that those plasmas and Earth-like phenomena. Well, let's learn about it. Let's learn, and that's going to help us to understand that as well. So there's. You need to have like liability protection for reporting, declassification, and pathways for any historical data, and allowing people to be able to get that, again, to study. That's what we want to do. We want to study it. We want to have data. Next, please. Number 8 is separate scientific study from threat assessment. Get away from the threat thing. That's the military stuff. We want to get scientific study going on, and that's where academia and a whole host of others come into play. They want to be able to study it. We want to make this a field of study in colleges and in universities and academia alike. The fact that you have you have Hakan Kayal over in Germany is got actually funding from the college for him to do this instrumented study. You have, even Harvard with Avi Loeb, I guess that there's funding for that and stuff like that, and it's the university. But anyway, the point is that we want to be able to get into that, and we want to be able to provide that. And just think if we could give some data to the, applied optical people up at UAH or some other organization, and have them look at the data. And they've got interns that can help us to learn, and we all put that in a common repository and help us to understand it. Wouldn't it be great? I'm dreaming on. Sorry, this is me after like 6 decades of just listening to, I saw a UFO last night. So anyway, we want to be able to get into scientific study with scientific body. We can catalog, we can analyze, we can assess the intent or threat, if we need to, is there a threat out there? But the separation is critical to maintaining international trust. Next slide. 9, start with a pilot, go out with a global instrumented study and do pilot. Do we choose a coast? Do we go to a desert? Do we go to a high traffic aerospace area? The point is that we need to go out with a pilot and show that there's success with a pilot, and then being able to create and publish our results and then have that all advertised and pushing for that. And I know that, that this is kind of like where Galileo is trying to go with what they're doing, but they're not covering the globe. They're covering in 3 locations here locally. And eventually they might get to the point where they're trying to do some sort of global thing, but we need global because this phenomena is everywhere. And so it's a global phenomena. Let's look at it globally. All right. And it's about time we have global transparency and have people pushing to support that. So early success creates momentum. And I just want to say that I can't underscore that we need to go out and get actively doing something. Next, please. And then number 10, maintain intellectual humility. We need to not repeat historical failures. We don't go with the assumption it's exotic origin or prosaic dismissal necessarily, but you're allowing the data to take you where you need to go with it, and allow multiple working hypotheses and treat UAP as a measured problem first, measurement problem. So I think we need to get into that kind of mode, get away from the endless speculation about things. And typically what happens is, you see a UFO video that's immediately put out there, hasn't even been looked at or studied first before it's put out there. It's on the evening news. The next thing you know is everybody's speculating about it. And we need to get away from that as well. So it's about the time where we actually do the heavy duty lifting and do the analysis and investigation first, and then come out with our results. Next, please. The challenges we got, well, there's a lot of those. Next, please. Go the slide. The key, if you take a look at what's going on in the world right now, a lot of political instability. You got countries, that are fighting each other. You got all kinds of political battles going on, whether it's, just basically instability is what I'm going to put it at. Economic instability. Does anybody know what's going to happen economically? And a lot of people are holding on to money. They're not wanting to necessarily give it away or do something with it. There are some few people that can do that. But it's just, we have these economic challenges to be able to create a global study. Then scientific cooperation and coordination. Again, we need to work on that. There's a stigma associated with this phenomena that we have to overcome. We still haven't got a lot of universities that will pay attention to, and allow it for it to happen. And so we got to get past that and get cooperation and coordination. And a lot of our scientific data that can help us write papers can be also help you to advocate in the universities and compete with that stigma. Because without it, it's everybody speculating about everything and nobody's got any data and they're not backing it up and they can't prove anything that they're saying. We have language challenges. Obviously, it's multinational. Let's get past that. There are tools that are out there to help us to be able to converse across the countries and the world. Again, I mentioned funding, standardization. We need to be able to utilize international standards. We're starting to have conversations with that. We'll have to overcome the data volume. And again, we need to incorporate machine learning and AI where we can. I mentioned the stigma and being objective in terms of what we do, and looking at our security in terms of how we're going to do that with our platforms. So lots of things going on. And I'll just bring up the last thing here, and that's a cooperative global UAP study succeeds only when it treats UAP as a data quality and a coordination challenge, not a belief debate or security anomaly. So with that, that's my presentation. I'm sorry for all the technical challenges we had before. And again, I apologize for that. I don't know, but I'm glad we were able to get through this in the time frame. And with that, thank you.
Excellent. That absolutely fabulous. I've learned like a college semester in just the last hour. I really appreciate that. And I jotted down so many questions, and I had to keep erasing them because you kept answering them as you went along. But and we do have some questions in the queue here, but I'll abuse my privilege here. I love the analogy you have of this new coordinated UAP studies thing with how astronomy works.
Yes.
And that's one of the things that I was thinking about listening to all of this, that we're kind of in the hobbyist phase now. It's like ham radio back in the day, in the 1920s, 1930s. And if you had the money, had the time, and a little bit crazy, you could pour your life and your sense into this. And how do we get past the hobbyist stage into something where astronomy is now? Because it seems to me that what astronomy is doing very well right now is being serious about accepting that there are amateurs in the field who are capable. They're not nut jobs, they're capable. And so many comets, I'll use that as the touchstone here. So many comets are discovered by amateurs, and they're reported to the AAU, and they're investigated and verified. And so how do we get to that type of structure from where we are? I think what you have, say, this is the structure that we need. Couldn't agree with that more. How do we get there from where we are now, especially because we do have to deal with the, as you put it, the belief debate? How do we get put that aside and get to a real functioning system here?
I do believe that it's going to, like you pointed out, it's hobbyist phase. If we get a lot of hobbyists, if we can get equipment out there, we can start to be collecting data that's going to, and it's also going to create the interest. I mentioned about the fact that you could also have the apps on smartphones, right? Which again creates the interest, right? Even SETI used our computers with the screensavers to be able to do distributed processing, correct? So if we had things like that to do, we just use that as that astronomy model, if you would, and also to be able to use that hobbyist mindset, and then to pre-position equipment out in the hotspots, much like what we do with our observatories by going to dark skies, correct? So now we're getting out to the dark skies, and we're setting up those things. Like if you look at in Hawaii, Mauna Kea or Haleakala, both have these observatories up there because it's the right place to be, right? To be able to see things. Well, so if we knew where like hotspot activity, and then we position that tiered kind of thing that I talked about, where you know where that's at, you can get that out there, then you're able to then tier up to those higher levels and have equipment or mobile kind of like platforms you can deploy to that. That's then going to help us to get to that information that we're like looking to get to. And then to couple that with the fact that you now have scientists or whatever like that analyzing the data, attempting to put that into papers, and they're tying that into universities. You're starting to build an accreditation, if you would, that allows you to have these scientific conversations, much like in astronomy, where they're starting to do that. And then we build ways of sharing that data from a global perspective, as opposed to here's my country, this is my country, this is my, and these separate little silos. Even in terms of the organizations we have in the United States, we got MUFON, we got this, we got that. Can we work cooperatively to put that like centralized thing together that supports all of us, if you would, but at the same time, then to build some sort of like, there might be a society like the Astronomical Society or something like that that's helping to bring that forward and help to. So if we just use the astronomy model, if you would, of how that going out, I think that we would be better off and get further down the road. And it's going to take cooperative mindsets. It's going to be the part that, for example, SUAPS is going to need to also help us to share that story, to get that story out, help us to get that centralized process. SCU is going to need to do the same thing. All these different organizations that are now like siloed, if you would, need to come together and to be more cooperative. And that's what I see that we need to do.
That sounds good. And the more data that can be collected by people, that forces the issue. It forces people to pay attention. Excellent.
Precisely.
Yes. So the first question, it was offline. I'll get to the YouTube chat questions next. It says, a lot of the work you described focuses on better sensors, more instrumentation, and collecting larger data sets. My question is about the scientific objective behind that effort. Are we primarily trying to demonstrate that the phenomenon exists or to understand what it actually is? In other words, if tomorrow we had absolute certainty that UAPs are real, would we still be investing in the same kinds of sensors and data collection, or would the nature of the scientific investigation change?
Well, let's put it this way. Just like we talked about with astronomy, we're continuously learning about the skies and things around us. Do I anticipate in any time in the near future that you're going to have, as everybody wants to talk about disclosure, that there's going to be a disclosure? UAP, we already have a government that's already said UAP are real, that it's a real phenomena. Whether we want to ignore that, that's fine. The United States has said that. Maybe not in other countries, but, the United States has already said that. With that already being stated, it's still, scientifically, what can we learn from it? Do we think that we're going to have an object that's going to come down necessarily and say, "Hi, here's how we fly"? No, we aren't going to have that. Do we think that now suddenly, just because the government says that that's the case, do we really think that we're going to continue to be able to ignore the fact that these objects are showing up, where they're doing? Do we understand the intent behind them? Do we know that? No, we're not going to know that. Okay. So until that landing happens and they come down and say, or they have a license plate on the back of the object that says that this one is from here, there, or wherever it's from, we're going to have to study it. And so studying is what science is about. And that's what we're going to continue to do. So regardless of what happens, we're going to need to continue to study, and we're going to learn from that. And sensors and various other kinds of equipment allow us to see beyond the anecdotal kind of testimony we get, where I saw something or I didn't see something or whatever, and that's not trustworthy. So we want to build trust and study.
Yeah, and I love that you phrase it, getting away from anecdotal, chasing these old stories. No, go
Old
out
stories.
and find new stories.
Yes.
So the next question we have is from Arnaldo. It's a two-part question. I'll give you both parts. You can do with it as you wish. Part one, he says, do you think we will eventually need to define a professional role that can be trained and certified, someone capable of coordinating the multidimensional requirements of UAP research? And part two, with competencies in strategy, intelligence analysis, engineering, technology, AI, epistemology, psychology, and related fields, question. It's a very broad profile that is not easy to find. So what do you think about the certification avenue?
No, I do think that we have to have accreditation and certification that ought to be a part of this. We want to be able to get to the point where we're acting professionally, if you would. And I've always looked at the fact that, where could I go and get a degree in ufology or UAP study or UAP science or some aspect to it. And I think that it would behoove us to be able to get those accredited kind of programs in place and to build some sort of a professional structure, and so I'm all behind that. I don't know what that model is, and I'm looking for people to make recommendations and help us to come up with that. Okay. I think that addressed the first part. And again, the second part was, I'm not really clear on that one. If you could.
I'll give the list again. Strategy, intelligence analysis, engineering, technology, AI, epistemology, psychology, and of course the related fields. So everything, basically. He left out philosophy, which is unfortunate, but that's a good list.
Yeah, right now, for example, I'm sure that you have it. We have it with SUAPS as well, but SCU is composed of all the kinds of disciplines, and we have collaboration across the board. And so we want to be able to share mutually and share ideas, and we'll all work together towards some sort of a cohesive strategy for understanding the phenomena from multiple standpoints. I mean, I still, value, the epistemological and all these other kinds of viewpoints. And we want psychologists to be able to get on board because there's a psychological component and sociology as well. So what are all the components behind this that are all going to help us to look at this phenomena? And, I don't necessarily think that the whole phenomena is composed of nuts and bolts things. There are potentially interdimensional kinds of things that we just don't understand yet that are popping in and popping out as well. There's, if you take a look at all the different hypotheses for where these things potentially could come from, it would drive you nuts because it's all over the board. And can we disprove any of those hypotheses? No. We can find elements or things where we can use each one of them, to be able to say, well, this looks like this looks like that. But we need to be able to study that. And again, it's not going to come from the scientists or the physicists. It's going to come from a whole bunch of other players. And that's where we have to have a more broad look at that. So by all means, a very broad look is very important.
Definitely. Yes, the new Renaissance man on that, yeah. Roman asks, regarding the sensors, how do we address the obvious issue of funding? How can we make sure people have access to the resources needed?
So again, we got to think about this like logically in the sense that sensors. By the way, sensors are also fallible. And we can misinterpret sensors. I was talking with Randy Bostic, who used to be a part of Aero, and we met in Dayton, Ohio. He was telling me about how they had sensors that they were putting out there that were picking up these strange objects and strange motions, and it turned out to be aircraft 300 miles away. And they didn't expect that was going to be the case, right? So you can have sensors that can give you a lot of information that's wrong information or not good enough information. And so bottom line is we need to understand the sensors. But again, what can we go out with initially? It might be something very simple in the sense of looking at, either magnetometers or looking with some low level kind of equipment that's affordable, that gets something out there, and then utilizing that to be able to say, is there activity in this area? So for example, if you took a look at the drone activity in New Jersey at the beginning of like last year and so all that crazy stuff that was going on, there was activity going on in the skies, right? And people were reporting it and seeing it, and they were calling them drones, right? And so they were saying there's drone here, drone there. They were being reported, they were being tracked, they were being looked at, right? So again, there's an example of where you have a repeatable event in a geographic area that you can take a look at. We call that a flap, by the way. But you have a flap going on in that given area, and now you bring in all the heavy hitting equipment. So now you're going to bring in the heavy equipment. So like, for example, what did Jerry and John Tedesco with the Nightcrawler do? They took their mobile platform, which has got like probably $1 million worth of equipment, and they drove it down and they positioned it, and they were starting to like look at it and collect information. And guess what? They said that some of those things were not, drones. They were UAP, right? And so they could help to look at that and see what we're going. So again, the same thing can apply here. We just don't know where to go with the activity and put those platforms like the top of Mauna Kea and Haleakala are to be able to go out and look up and see what we want in the skies and collect that. And so that's where it's using your money in the best way possible to get the best way forward, right?
Yeah. Now, it's the challenges in so many dimensions of that. It's necessary. It's what we got to do. But yeah. A lot of good people need to do a lot of good work on this. Yes. Next question is by Helimetal. How do we reconcile national security with transparency when sharing data collected by military assets that could possibly expose intelligence collection capabilities or limitations?
Yeah, well, let's put it this way. I work with the DoD, and I was doing things where they, if you take a look at even the Nimitz case or some of the other things like the gimbal and you can provide scientists with stripped off metadata. In other words, you don't get the location data. You don't get some of the more sensitive aspects of that military tactics and procedures that you imply. But at the same time, you give just that visual image, and you'd be surprised what we can do with that. Like we studied, for example, for close to 2 years, the Nimitz case. We interviewed 18 people that were part of that in SCU. We talked with all these different parties and players, and we were able to put together a 277-page paper that talked about that and we were able to look at the video and deduce all different kinds of things we could from it, in terms of seeing that it was moving at like close to Mach 50 and above. And what can you do with an object that's dropping from 20,000 feet and stopping above the water in 0.78 of a second? Well, you can look at the physics of that, and you can find out that it's going like Mach 50 at dropping down and leaves no acoustics or kinematics or anything like that. No kinetic energy release, and so you can still learn scientifically from that data. And I think the government needs to be to the point where it can do that. It can provide certain bits of data and not give away classified information. At the same time, that I think that it does behoove us. I will say this much: I do support defense, looking at defense issues, and I support them in looking at classified data and dealing with it, because it could potentially be a threat or it could be a safety issue. So I think we need to do that. But again, I think that there's a certain aspects of that can be shared with academia. I know that we have CRADAs, which are cooperative research agreements with defense information between universities. And for example, the university here in Huntsville is working with the Redstone Arsenal and supporting that. And they get data that's stripped of that kind of information, and they can help study. So I think that we need to look at that as well. But I don't hold out for that. But we are trying to have cooperative a relationship with Aero and getting them to be a little bit more transparent with us as an organization. And there's been some positive moves in that direction, but I don't expect much.
Fair enough. Yeah, it's some ways to go in that relationship, to be sure, on both ends. Michael Sifone, our executive director of the Society of UAP Studies, he has asked to chime in, and how could I say no?
Exactly. Rich, amazing talk, really fantastic. You covered it all. I really like, your sort of your emphasis on the importance of having a global, interconnected, interoperable sort of data ecosystem, and which is also friendly, respectful, and acknowledging of the importance of citizen science, amateur, if you will. We have systems in place. We've got NASA, for example, that's done that. We've got platforms within which citizen science can be conducted. So let's, right. I mean, I just want to second, your call for that kind of international cooperation, but also nationally, calling for citizens to be participating in data analysis, identification, maybe in combination with AI systems, to be able to process the data that we've got, right? I mean, you talked about UAPX, that years ago, terabytes of data. There's a lot of stuff that needs to be worked on, processed, and let's get citizens involved. That's partly what, the society here we're trying to do. We're trying to get people interested, become members, supporters, and then be able to create those citizen science ecosystem infrastructure interfaces where we can actively engage people, not just educationally, but also materially, working on these data analysis problems, being part of the actual action, right, of data. So thanks. I mean, Rich, such a great talk. You covered it all. As we're kind of coming towards the end today, I wanted to actually talk about you. I mean, going back to your history, when I met you, I think 4 or 5 years ago, I remember you telling some stories about, as a young researcher, right, getting involved in these cases, right, which is what I like to call the sort of classical ufology, where, you jump on the scene where a case was reported and you try to recover whatever, trace evidence, interview witnesses, and you involve yourself in that sort of forensic investigation. I want to ask you, of the cases that you've personally engaged, can you pick two or three, one or two even, that really for you stand out in your experience, and talk to our community about that? I wanted to go back to you, Rich
Yes, well,
Hoffman, as an investigator.
yeah, I mean, my whole start was in doing that, like you say, that field investigation where you would actually go out immediately after you get the report and you're out there talking, very much like what you would expect that Project Blue Book and would have been doing. In fact, when I got started, I was out doing investigations, and I would end up having a Blue Book officer who was doing the same case sitting in next to me. You know, I had a few experiences like that, and so we were sharing notes and stuff like that when I was doing my case investigations and stuff like that. But you're out there talking with witnesses, and usually it's after the fact, so it's not, you know, it's like you missed being there, of course, at the same time, but you were called to go to a scene. I would have even my name was in all the police departments, and I would have the police would call me up and said, we got like 12 people out here looking at something right now. They're calling it a UFO. We'll come out and get you. So they would actually come out and get me with the cruiser lights going, and we would flash out, and I'd go out to the scene where all these 12 people are now looking at the planet Venus. and I'd have to tell them, well, I'm sorry, you're looking at the planet Venus, you know. And okay, so that would be kind of frustrating for them, but you know, then I'd have to show them, you know, on charts or something like that where planet Venus was and why that was being misidentified. But I had very incredible experiences. Like, you know, I had one case that to me was, I call it my aha moment, that there was something to this. Not that I've ever seen one, right? I've seen something that I thought once was, and it turned out to be the Google Loon balloon. But anyway, I was basically investigating a case where a farmer, there had been a lot of UFO activity over the course of the evening in this one given area. And a farmer is now looking out of his second floor building or his house, and he's looking out at his wheat crop. And in the middle of the wheat crop, there is a perfect circular area where he's lost his wheat. And, you know, it's like, well, what could have done that, you know? And eventually we were called, and the state director and a whole bunch of other for Ohio, and we went out and we started like cordoning off and looking and doing our research on that. And so sure enough, in the middle of the field, and there's no indication that you're bringing in heavy equipment and stuff like that, but in the middle of the field is this area where the ground has been baked 2 feet in 2 feet deep. And there's no wheat crop there anymore. It's like it's where to go. And even the roots were gone, you know, of the wheat below surface. And you're thinking like, well, that's potentially maybe like a microwave kind of thing that was going on or something of that nature. But then the interesting thing about it was that there's a central depressed area in the middle of that 70-foot area. And then as you go out progressively, then as you get out on the outer perimeter of this, you start to see a little bit of stubble that's sticking up out of the ground. And then you'll get out a little bit further, and there's a rotational pattern. And then you also have an area 70 foot in diameter of puffed wheat. So something has now heated and puffed that wheat around that 70-foot area. So what you're talking about is like an incredible experience here. Whatever it was, how did it do it? How can you possibly replicate and say, well, it's something else? And you're standing in the middle of that, and it's like your aha moment, because you're saying, I can't begin to explain this. This is way beyond me. This is like, you know, this doesn't even make any sense. And it had to have come from above, and it came down, and, you know, and so that alone was pretty incredible for me in terms of that experience. And then, you know, I would be out in countless investigations and stuff like that. And I would see, like, I was on, I got to be known on TV and stuff like that around the Dayton area. And I had a couple that called me up, and they said that they hadn't told anybody. I'm the first one that they're going to tell. And they lived around a pond, and on this pond. And one evening, they were their back bedroom became lit up, and there was something like of an orange object that was out above the pond. And they said, well, we haven't told anybody about this, but we're telling you. So they told me that story. And they said that even there are 3 houses around the pond. So the next door neighbor, their kid was over mowing their lawn a couple of days after that and said to them, hey, did you see the orange object over our pond? And they refused to even acknowledge the fact that they had seen it at all, right? You know, they didn't even do that, but they were aware of the fact that the kid said that. Well, then it got to be interesting. I said, well, can I find who was living in the 3rd house? And did that person happen to experience anything? And eventually I found out that there was a man and a woman, and the man had died. And of course, this is years and years later, but the woman told me about the fact that her husband had said something about seeing an orange light above it, had gone out and looked at it. And she didn't know that he slipped out in the course of the evening. And the next morning he came in, he was nude, his hair had turned white, and he was mumbling about something that was an orange light out there in the pond. So I just want to emphasize here that the vast majority of people, the stranger the story, the less likely that people will even open about it. They don't report it. And so the vast majority of these things go unreported. And nobody knows who to report it to and everything. So we're doing a very poor job of collecting information and dealing with it. But the bottom line is we got to get our act together on that and really truly get people to be willing to help us to learn more, whether it's giving them tools on their phone to alert them to activity in their local area, and then have them go out and take photos, and we can use triangulation to do our analysis and study. But Mike, that's what's going on. And, you know, I gave lectures I even gave a lecture to Foreign Technology Division at Wright-Patterson Air Force Base. And during the course of my talk with them, there were about 40 people in the room. I asked how many people had seen a UFO, and a nervous hand went up and said, yeah, I saw something. And then after the break, they all came individually up, telling me their individual stories about the case that they would tell me privately. One guy came up and said, you know, my job was to collect gun footage camera off of aircraft because we were chasing the objects. And his job was to collect that, and they would get debriefed and they couldn't talk about it and so on and so forth. You know, where's all that video information that they collected from those kind of like gun camera mounts? Do you see that out of Project Blue Book? No. Do you see all that? Do we press for that? No. And so again, it's about what do we do with our data and information, and how is that being shared to allow us to study this stuff? And it's all in the back door. But I've had so many cases and so many investigations, probably thousands of them. And I was the director for Alabama and Mississippi. I got strange stories that could keep you going for a long time.
We're gonna have you come back for a fireside chat on crazy highlights.
There you go. I'll do that.
So when are you going to write your memoirs, Rich? We're waiting.
Well, I know it's
really
funny. Like I said, as soon as I retire, I'll do that. But I've been busier than heck with the UFO thing ever since I retired. It's like, my God, I'm on podcasts every day, or I'm on a show. I'm doing TV with the Proof Is Out There. I'm going to be on the next season of that again. And there's just so much to do. And now this technology thing is near and dear to my heart. And I'd like to see us get our act together over that. And that's what Heineck wanted years ago. And I'm looking to be able to help share his message.
Yeah. Yes, absolutely. This is an exciting time. There's absolutely no point in retiring right now. No point at all in that.
That's right. Anyway,
I don't see any other questions, and we're approaching the 2-hour mark here. Do you have any last things you wish to say?
Well, nothing more than just wanting to acknowledge the fact that Michael, what you've created here is. I know we were back at the very beginning of that. I remember when we were up in Vernal, you talked about wanting to put something together, and so I'm applauding you for that, because you've done a remarkable job with SUAPS, and I'm behind you 100%. I think the educational component to this is extremely critical, and we need to do that. And training is just right up in the forefront of that. And and then the journal work you're doing with Limina and all that is just, it's sorely needed. So I just want to say kudos to you, Mike, and Doug, for doing what you're doing here. That we need more of this, and I thank you from the bottom of my heart for doing it.
Thanks. Rich. SCU and your work on all of these really detailed case reports, from Nimitz to Stephenville to Aguadilla. This was my, when I was getting into this racket, as we say in South Philly. I was deeply impressed by your work. You and your colleagues, of course, Robert Powell and Peter Riali, Sarah Little, and the whole team there. Wonderful. So SAU, yeah, it's close to my heart. We work well as a team together. So SUAPS is here. It has a more general mission, but it's certainly focused on that kind of case, investigation work that SCU is doing. So we support fully SCU as well. We're really honored to have you as an advisory board member. This year, we look forward more engagement between members internally and also with the community at large. We're working really hard to develop that funding. This is the whole point of this, to get as many people interested in materially supporting us, but then converting that material resource into tools, right? Educational opportunities, of course, but also grants, scholarships for students, fellowships for academics actually working in this field. So I think we're fully aligned. Your vision for that sort of global international data standards and ecosystem of exchange, 100%. We're talking about that professionalization. You talked about that. Here in Brazil, I'm not sure if you know this, but it's probably the first government in the world, perhaps in history, to actually acknowledge, now maybe for tax purposes, but certainly officially, to acknowledge ufology as a profession. So this is, I think this may be a model actually for the rest of the world. Possibly to consider, right? To taking it out of the sort of shadows, respecting it with acknowledging that it is a profession, and as a profession requires standards, certification, a curriculum, right? Yes. And some kind of regular cycle to move from interest to professional practitioner in the field, right? And you've got the science you mentioned, but you've also got the ufology, right? The case investigation. And what I've seen in your career, right? You bring, you're working on both sides of that divide, right? You got the classical ufology, but then you got this emerging science that we're all participating in, helping provide those foundations for. And that's what we're seeing now, is that we're getting serious about it. We need serious standards, standards of evidence, standards of professionalization. So Rich, you embody a lot of that, and you stand, from history, from Blue Book. It's amazing. Your story is amazing. From Blue Book to the sort of post-2017, post-2021 world where we're acknowledging the reality, we're getting past that question, and now we're getting serious, rolling up the sleeves and actually doing the science. Rich, again, thank you so much. It's always an absolute 100% honor. Douglas, I'll give you the final word. Thanks.
Yes. And again, I can't thank Rich enough. I can't thank Mike enough. And I just want to say to our public who are watching live and the thousands of people who watch the recording of this, you have a role to play in this as well. The Society is an academic organization. It's a learned organization, but it's one that's open to the public. It's one that is reaching out to the public. You can become a supporting member of the Society. Go to societyforuapstudies.org. You'll have access to many more materials. I also want to plug, we have a reading circle. You can go to the website and find out about that. In 2 weeks, I'm leading the discussion on the book by Michael Swords and Robert Paul entitled UFOs and Government, A Historical Inquiry, where people like you can talk about this with people who are also interested. And think about membership in the society like a membership in NPR or PBS. Your money is going to pay for programming, is going to pay for, in our case, research. The things that Rich Hoffman have been talking to you about, that's, as Mike said, that's the vision that we have here at the Society. That's the thing we want to accomplish. You can help us do that by becoming a member and supporting us. So thank you very much for tuning in. Thank you, Rich, for your wonderful presentation. And roll credits, and we'll see you in 2 weeks. Massimo Teodarani will be our next presenter.